Hello, everyone. Welcome to the course of Fundamentals and the Principle of Non-Destructive Testing. I am Luna Lu, a professor at Lyle School of Civil Engineering at Purdue University. In this next 5 weeks, we're going to cover 5 learning objectives. First, we will understand what the importance of the non-destructive testing. So why the NDT? And then we'll understand the purpose of non-destructive testing, what we're trying to achieve. One thing is very important, it will build the fundamental knowledge about the typical material and structure defects and the failure mechanisms. From there, we will discuss the principles of wave propagation and the wave stress relations, and then related various NDT methods. So at the end of this course, everyone should have a good knowledge base and understanding that enables you dive deep in the different types of the NDT methods, which we'll cover in the course number 2 and number 3. So let's dive in. First, let's answer this question: why non-destructive testing and sensing? Every day we travel on roads, bridges, and highways without considering the safety and the reliability of the structures. However, much of this transportation infrastructure in the United States actually is outdated, deteriorating, and badly in need of repair. And for instance, here are some statistic numbers, and it has been showing 1/3 of the dams failure since 1874. Out of 6 million of the bridges in the United States, 13.6 of them are structure obsolete and 9% are structure deficient to daily traffic volume. As a consequence, the traffic jams caused by insufficient infrastructure waste about 4 billion hours and nearly 3 billion gallons of gasoline per year. There are numerous cases of one crack at a materials level has led to catastrophic failure of the structures and also resulted in losses of lives and property damage. The Silver Bridge is one of such example, and it's well known, the Silver Bridge accident. This is the I-bar chain suspension bridge, was built in 1928 over the Ohio River on the US 35. On December 15, 1967, the collapse happened during the rush hour traffic, which has caused the death of the 46 people. And really the cause of this failure was a single I-bar in the suspension chain has a very small crack, which is about 0.1 inch defect. Caused by the stress corrosion over the years. If this defect has been identified earlier and has been repaired, which may not lead to this catastrophic failure and such a tragedy. So Interstate 35 Mississippi River Bridge collapsed in 2007. This is another very famous case study, has often been used in civil engineering discipline. As the video showing here, the bridge was collapsed all of a sudden during the rush hour and caused 13 people killed and 245 injured. And this is much to be contributed to the design error, and there was undersized the gusset plate and also the lack of the routine check for concrete and the steel corrosion. There's some crack has been clearly appeared on the bridge, which was not being identified. A similar story has leads to another very big incident in 2018, Florida International University. They were building a pedestrian bridge and it was also collapsed and resulting 6 deaths, 8 injuries, and 8 vehicles being crushed underneath. Again, there was some calculation error in the bridge design. However, part of the reason also because of lack of the identification of the structure cracks in part of the structure nodes, particularly on the north end of this bridge deck. So many of you may know in this incident, a Hard Rock Cafe was collapsed in 2019 on downtown New Orleans. When the contractor was building in this project, they used a poor quality of the concrete, and then without doing proper testing, they start demolding way earlier than the concrete reached to the critical strengths. And this incident has led to 3 workers and injured more than a dozen of the others. So it would be very good if we have in situ real-time monitoring system to monitor the concrete strengths, and that will send alarm to any inappropriate operation. This tragedy could be definitely avoided. A very similar accident has happened internationally in Taipei Bridge in 2019. And 6 people was dead and 12 people got injured. And there is, I have posted some YouTube video here. If you're interested, you can see the entire process. It's really heart-wrenching. And then as you can see, there was a boat has been sunk and underneath, and then there was a car and tried to make it and unfortunately did not make it during the bridge, and the entire cable was breaking into the pieces. Again, the cause is the very small crack on the cable due to the corrosion of the cable and the anchorage devices. So if this crack has been identified earlier and has been repaired, and those type of the tragedy can clearly be avoided. So one of the most recent accident is happened due to the lack of the inspection is the Edenville Dam, which collapsed in earlier this year in Michigan due to a heavy rain, um, ranging from 6 to 8 inches. That's built a lot of the stress on the concrete. And then that's eventually leads to a part of the concrete structure has been collapsed. And over 10,000 people affected, 2,000 homes damaged. Luckily, nobody has severely injured or caused any death in this accident. However, this damage has cost over $250 million property damage. So we can give numerous cases of how a small defect at the materials or structural level can lead to a catastrophic failure of the entire civil infrastructure system. So therefore, it is very important to use some sort of a non-destructive testing methods to evaluate, to categorize the property of the material components, structural system without causing any damage, and really to identify the discontinuity or the defects at the very early stage and to come out some remediation plan. So that is the purpose of the non-destructive testing. So by definition, it's really a wide range of the testing and analytical methods to evaluate the property of the material and component structures. And here I have some examples to show you. For instance, on the left, as you can see here, this is a typical X-ray diffraction image, and then we could see some of the voids and the defects of the welding, right? Of course, to get this type of image, you need to do scanning electron microscope, you need to cut the sample, you need polishing the sample, which is definitely cause the damage, right? So when we're doing the testing for to identify the welding in service, what we could do, right, rather than doing this type of the image processing, we could use the ultrasound here as been showing here, right? So by using the ultrasound, send acoustic wave by analyze the wave has been propagated and reflected, we could get the imaging of the welding quality of the hair, if there is any voids or not, right? So that's one example. And another example is we typically see when we try to understand the strengths or mechanical property of the concrete or steel, we will do destructive testing to break the testing sample. On the other hand, we could just use the type of the sensing methods by sending the wave and then to understand the resonant frequency of the material, and we could understand the mechanical property, which we will talk more in depth in the next couple classes. So as this example has been showing here, non-destructive testing is really try to understand the material property without causing any damage to the test part or the objects, right? So sometimes this NDT can refer to NDE, non-destructive evaluation, or non-destructive inspection. As we have been discussed, it can definitely play a critical role in preventing material and structures failure, and can also to avoid some catastrophic failure at the larger scale. So in this class, what are we going to learn, right? So there is 5 major topics of the NDT. In this first short 5 weeks class, we're going to study the fundamentals of non-destructive testing. That's including, what are the non-destructive testing methods? What are the typical standard of error of non-destructive testing methods, and then we really need to understand the structure integrity and the failure mechanism, which will spend about 2 weeks to discuss various mechanical property of the material and how this could lead to the catastrophic failure if we're not dressed properly. And then we will spend 1 week to understand the wave propagation and the wave stress relationship in the structure level. And then in the course number 2, we will study various wave-based non-destructive testing methods such as ultrasound, such as ultrasound pulse velocity, such as acoustic emission, such as electromechanical impedance methods. And then the course number 3 will study most of the electrical-based NDT methods, such as your thermographic, your eddy current, and the radiographic methods, and the magnetic-based methods. So that's how entire course will be structured. Again, at the end of this course, you should have a fundamental knowledge base that enable you to dive into the various wave-based NDT methods, electrical-based NDT methods, and really understand how we're going to use these NDT methods and how to interpret the data and what are the limitations and advantage for each method. So with that being said, I want to quickly show you a couple of examples. For instance, in this slides I'm been showing you is my research group using electromechanical impedance methods to monitor concrete strengths, as been showing in Hard Rock Cafe. Right, so what if this laboratory scale can be scaled up for the field implementation? So the fundamental methods is to really send the mechanical elastic acoustic wave into the concrete, and then what we're measuring is mechanical impedance, is basically force over the velocity of this wave, which is really closely dependent on the material's stiffness. So therefore, by measuring the acoustic wave propagation in the material, we can all of a sudden understand the stiffness development of the material, as we know, which is linearly with the strength, so we can understand the strength development. So imagine if this type of the monitoring system in the real field during the construction, that will really avoid, the catastrophic failures such as we have been showing in Hard Rock Cafe in New Orleans in 2019. So here is another examples how the people using the ultrasound inspection to detect the discontinuity on the pipeline, and by looking at how the wave propagates and how wave will scatter and then reflected back to the receiver. So this class will dive into the details and for fundamental underlying principles of physics, and then we will also discuss how the testing setup, what are the devices, and what are the data we're receiving, and how we interpret the data. So some other examples, and then the researchers or the engineers start using fiber optics and looking at the stress and the corrosion of the rebars, and then from there to can understand the structure integrity of the materials and at the structure level. So here is examples, and the people using the eddy current to understand the corrosion. In this particular case, is we have a probe which is going through AC current through electromagnetic induction. That probe will generate the secondary magnetic field and induce the eddy current by looking at the pattern of the eddy current and particular impedance of your eddy current, and then all of a sudden we have vast knowledge of the thickness of these parts and if there is any corrosion, and then all of a sudden we could understand if there is any crack, if what is a residual stress. So non-destructive testing methods, if you use it properly, it can give us a lot of knowledge, right? And the hidden mystery about the parts of the structures. So how we learn this in this class, we're going to primarily use a textbook. It's called The Fundamental of the Structure Integrity, which is written by Professor Grant, one of my colleagues at Purdue University from aerospace engineering. And this is a widely respected textbook and widely used in NDT community. And then if you can search on the Google, actually, I think most of you probably can get a free copy of this called the Non-Destructive Testing Methods for Evaluation of the Concreting Structure, reported American Concrete Institute 228 committee. And this is also a very good reference book. Now I would like to spend a minute to discuss how we graded the academic performance of each student. There will be three components. First, the homework will count about 30%, and each week we'll have one quiz, including multiple questions, the true false, and then the total of the quiz will be count for 40%. And the last one is a term paper will be requested by, to submit at the end of the semester, at the end of the 5 weeks by each of the students. That will count about 30%. So the detailed expectation and the requirement on the term paper will be discussed at the end of this class. With that, I would like to wrap it up for this short video, and coming next, we'll talk about introduction to non-destructive testing.